Hello, Alvin ISD mathematicians. Today we're going to be reasoning with ratios and rates. So what does that really look like today? Well, today we're going to be solving real-world problems involving ratios and rates by using strip diagrams and ratio tables. Remember, you've already learned that a ratio is a comparison of two or more things, and a proportion is when you have equivalent ratios. Guys, this is actually something that is really important that we learn because we use rates when we drive, when you calculate how much you're going to owe for something at the store, or how much a % of discount will be. And as the picture shows, obviously, we want to learn this so we can get the best deal on our chicken wings. Guys, this is what our final destination is going to look like after our learning today. So by the end of today's lesson, you will be able to get this question using multiple strategies with ratios. So the first thing that we want to do is kind of warm up our brain a little bit with a brain teaser. So this is today's number, and you want to represent today's number in as many possible ways as you can. So consider using some words, pictures, graphs, numbers, symbols, equations, examples, etc. Anything that you can think of. And guys, there is no wrong answer to this. So just record as much as you can think of. All right, welcome back. So this was how I thought to represent today's number. So notice on today's number, I represented the 2 to the 3 using integer chips because I remember using those in the beginning of math. And so for every 2 yellow, there were 3 red. And I also represented that in my table on the right. Well, and I remembered if there was 2 yellow and 3 red, that meant that there was a total of 5. So yellow represented my part. Red also represented my part. So I compared my part and my part to my whole of 5. Well, then I thought, well, what if I doubled that? If I doubled it, I would have 4 yellow, 6 red, which would give me my total of 10. I also represented it in a strip diagram right here. So for every 2 yellow boxes, there was 3 red. And then I represented our ratio in the 2 other ways that we can, using our fraction bar and also using our word ratio. So we're going to start off today by modeling ratios and rates. We're going to actually be using strip diagrams to do this. So if you scroll over to your Math Tools bookshelf, we'll be using these thinking blocks today. So go ahead and take a moment, pause the video, and go to the link that's attached to the strip diagrams, and then come back when you're ready to learn. The first question that we'll be looking at is, what if we are solving for a missing quantity? So let's look at our problem. Haley and Jason shared some pencils in the ratio of 8 to 5. If Jason has 40 pencils, how many does Haley have? So they want us to read the problem, which we just did, identify our ratio. Well, our ratio is Jason's pencils to Haley's pencils. So I'm going to drag my labels, and let's check. All right, and now we want to build our model of the ratio. So it said the ratio of Haley to Jason is 8 to 5, which means Haley has 8 because order matters when we're building ratios. And Jason has 5. We want to know how many pencils Haley has. Well, 40 represents Jason's whole, which I recognize I can equally share 40 into those 5 boxes by dividing 40 by 5. So each individual box represents 8, and if Haley has 8 boxes, then she has 64 pencils. Awesome. On our previous example, we were given a part and then asked to use that to find our missing values. But now, what if we're given the total and asked to solve for a missing value? The sum of two numbers is 60. The ratio of the bigger number or the greater number to the smaller number is 7 to 3. What is the smaller number? So I'm going to identify my ratio, which is bigger number to smaller number. And that ratio is 7 to 3. And again, since order matters, the greater number gets 7 blocks, and the smaller number will only get 3. It says the sum of the two numbers. So the sum represents 60. And I'm solving for my smaller value. If the sum represents 60, then I need to share 60 in between to 10 different blocks. So that means that each block will represent 6. So the smaller number is 3 groups of 6, which is 18. We just used the total to solve for a missing part. So now what if we're solving for the difference between two of our values? The ratio of the length of Tina's string to the length of Noah's string is 5 to 7. Noah's string is 18 inches longer than Tina's string. How long is Tina's string? So we are comparing Tina's string to Noah's string. And since order matters, the ratio is 5 to 7. 5 square tiles would go with Tina's string. 7 will go with Noah's string. So it says Noah's string is 18 inches longer than Tina's. So this 18 represents how much longer Noah's is. And we want to know how long Tina's string is. Since these are equivalent ratios between our model and the numerical value, this 18 represents the value of 2 blocks. When we're dividing or sharing equally, that 18 splits into 9 for each block. So if each block represents 9, and Tina has 5 blocks, then Tina's value is 45. So her string is 45 inches. So we just modeled rates and ratios with concrete models using our tiles. Now we want to think, how can I represent my thinking using strip diagrams? So we're moving from concrete to representing by drawing. So Elena has 3 times as many beads as Mary. If Elena has 600 beads, how many do they have all together? So I know Elena and Mary. And Elena has 3 times as many as Mary, which means for every one that Mary has, Elena has 3. And then they told me that Elena has 600 beads. So Elena is equal to 600. And we want to know how many they have all together. Well, if Elena has 600 and we want to share that equally with her 3 tiles, each tile is 200. Which means Mary has 200. So altogether, they would have 600 plus 200, which gives you a value of 800 total beads. One day there were 2 choices for school lunches, spaghetti or pizza. 3 out of every 5 students who got the school lunch chose spaghetti. If 250 students got the school lunch, how many more students ate spaghetti than pizza? So now I'm going to represent my thinking using a ratio table. So 3 out of every 5 students get spaghetti. That means the other 2 get pizza. So 3 to 2 is my ratio for my part to my part. But my whole, so the total number of students, in this case would be 5. Because 3 out of 5 got spaghetti, which means 2 out of 5 would have had to get pizza. Well, 250 students got lunch. So 250 will go under students column. And again, I have to think multiplicatively. So I know that to get from 5 to 250, I can multiply by 50, which means I'll multiply 2 by 50 to find out that 100 students got pizza, and 3 by 50 to find that 150 students got spaghetti. Well, they are asking us how many more students ate spaghetti than pizza. Well, 50 more students. I subtracted 100 from 150. I can also represent this relationship using our strip diagrams that we used on the previous example. If I know that we have 3 out of 5 students that get spaghetti. So we have spaghetti, spaghetti, and spaghetti. That means that the remaining 2 ordered pizza. So here, visually, we see our 3 to 2 ratio. And then they tell us that 250 students total got lunch. So that 250 represents my entire strip diagram. So I need to share 250 equally into 5 groups, which is division. So each group gets a value of 50. So I can see that 150 students got spaghetti and 100 students got pizza. So 50 more students chose spaghetti. Again, guys, this is the same way to solve the problem. We use the same kind of thinking. It was just a different way to represent it. Is there more than one strategy that we can use? Obviously, we know that's yes, because on the previous example, we did use 2 different strategies. So moving forward, as you learn and play around with these strategies, I want you to be thinking about which one is efficient for you and makes the most sense. So a window washer cleaned 38 windows in 2 hours. At the same rate, how many windows did he clean in 7 hours? So I'm going to use my strategy of a ratio table, because this is what makes the most sense to me. If you want to use the strip diagram, I will model that thinking as soon as I'm done with the ratio table. So we're comparing the rate of windows to time. And I know that I can wash 38 windows in 2 hours. But I want to figure out how many windows I can clean in 7 hours. So I'm actually going to divide to my unit rate. So if I can wash 38 windows in 1 hour, then I can divide by 2 on both sides of my ratio table to find my unit rate of 19 windows in every hour. If I know my unit rate, then I can find any value of windows if I'm given the time. So to go from 1 to 7, I'll simply multiply by 7. And so then 19 times 7, I'm going to come over here and do my work. 7 groups of 9 is 63. 7 groups of 1 plus our 6 is 13. So I can wash 133 windows in 7 hours. Now again, the same thinking can be applied using a strip diagram. If you can wash 38 windows in 2 hours, so that means each hour, here we go, and it's equal to 38 total windows. That means that every hour is 19 windows. So again, guys, notice it's the same thinking. We just found our unit rate. And if I know that unit rate, I'll still have to do the same process of multiplying up by 7 to find how many windows we can wash in 7 hours. All right, guys, we have reached the end of our lesson. At this time, I want you to take a moment to pause the video and attempt this question on your own. Please use any of the strategies that you have seen today and that make the most sense to you. Whenever you're done with the problem, please join the class again and we'll check our solution. All right, guys, welcome back. So we have the ratio of boys to girls in Miss Cunningham's class is 2 to 3, and we have 18 girls in the class. What is the total number of students in Miss Cunningham's class? Well, I'm going to start with a strip diagram. So I see that the ratio is 2 to 3, which means 2 boys for every 3 girls. And then they tell me some very important information that there are 18 girls in the class. So these 3 tiles that I have written G in represent 18. So I want to share evenly or divide 18 into 3 groups. So each tile is equivalent to 6, which means each tile for the boys is also equivalent to 6. And notice we now have 5 groups of 6, which is 30. So she has 30 students in her class. We can represent this with a table. So we still have our boys to girls, notice which is a part-to-part ratio. So we're comparing part of the whole to another part of the whole. So it is 2 to a 3. But that gives us a total of 5. For every 2 out of 5 students, they're boys, and for every 3 out of 5 students, they're girls. We were given again that it was 18 girls. And we want to know total now. So we want to know this. So I see I can multiply 3 by 6 right here to find 18, which means 2 times 6 gives me 12 boys, and 5 times 6 gives me the 30 total. And our part plus our part should equal our whole here. And again, it matches our other strategy. Thank you so much for learning with us today, boys and girls.